Hello. Today, I want to share some stories and especially the lessons learned from my experiences optimizing React apps. Who am I? I'm Nik Graf. I'm a consultant, so I help teams with the front end to improve the architecture, to train juniors and seniors. And yeah, I'm also an ACAD tutor and I work on projects like ChangeFeed and Serenity. First of all, spoiler alert, I'm not gonna talk about the usual suspects today. So React memo use, callback, should component update. There are a lot of like really good resources out there. I want to actually focus on a couple of real world cases that were not solved by these utils. So let's get started. The first example I want to take is basically an application. It was a web application embedded in a native app, and it had at the bottom it had like a tab navigation. For example, like here you can see it. When you click on it, you basically switch the screen. In this case, it was early on a requirement that it also should be swipeable. So the customer or the users could actually swipe between the screens. And what we had very old devices as well, and we got the feedback that for the old but also for newer devices, switching between tabs or screens takes a long time. So what do? Well, the first thing you do, you measure. And well, fortunately or unfortunately, this was so slow that we didn't even need to take a profile. You could just like count the seconds with a stopwatch. Because on a modern MacBook Pro, well, relatively modern 2017, it took about 1 second to actually like finish from the click or from the swipe that you started to the next screen, to like really finish building up the UI. And the oldest supported device that we had was a 2014 Android running Chrome 33, and that was really bad. It was 5 seconds. I mean, this is where you really can you can get a coffee in the meantime while loading this, or even a 3-course meal. All right, but then from there on, well, it's bad, so you have to do something about it. So usually you go, or that's what I usually do, is you start profiling. So the performance panel of Chrome, for example, has this profiling, so you can click record and then it shows you a lot of like what's happening. And what we saw here is this area, basically when you're switching a screen, you were waiting on the MacBook 760 milliseconds. It took to switch from one to the other. And you can't see this here, but if you then further go down here, you actually see the functions that are invoked, and you figure out like what is taking so long. And you can see like 2 things were rendered, and then all the functions that are called. And this led us to one particular code area, and this was the swiper component. And yeah, well, first of all, we have never seen this. It was written by someone who already left the company. So we started to investigate, like, why is this there and what does it do? Luckily, there was a comment, and it said render only visible and visited tabs. And that sounds pretty decent. I mean, you don't, if you have a router, you don't want to render all the tabs right away. You only want to render at least what you're on. It was very interesting that it said like the already visited tabs. But if I'm not mistaken, React Navigation for React Native also does the same. That like once you open the tab, it's never really unmounted. but I'm not entirely sure. But this sounded pretty decent. And what this code does, it used a swipe component because we had this swipe feature that was required, and then basically it was on change. It was calling on the props activate. So somewhere up the tree there was the current active state rendered, but probably wherever the tabs came from. Because they're already pre-rendered with the children. And one thing that really struck us though, that we had this like 2 renders that were there, and we're really curious like why this is happening, and what it turned out to be, or like where we started to try out different things, is like we took away, and also you could see it a little bit from the in the tree that React clone element was taking very long, and what we did is we simply changed it to this here. So the React clone element, where the active tab the children were replaced with a property active, so that the tab actually, or the screen actually knows that it's active. And yeah, we just for experimentation, we were trying out what if we don't do this and we just render the children and leave it be. And what happened was very fascinating. Basically, it was like full-on success. From 760 milliseconds, we went down to 80. And this was fantastic. I mean, this was like a 9x, 10x. Really excellent. We were really, really happy. There's one concern. Didn't we just like turn off a feature? I mean, the screens were giving the prop or the information that they're currently active, basically here, this active part. But the thing was, it wasn't even used. This was the best part. I mean, if it would have been, we would have probably found another way to make this happen. Maybe using context and bypassing that you have to really re-render this. But yeah, it wasn't used, so we simply could move on, and the results were phenomenal. Not only on this MacBook, where we went from 800 to roughly 90 milliseconds constantly. We were also on the slow device, went from 5 seconds to 1 second, and I mean the experience change is tremendous. From 5 to 1 second, this is really, really fantastic. And I mean, 1 second is still slow. Don't get me wrong. This is like horrible, but like on such an old device compared to all the other experiences, this was pretty decent, and we were really, really happy. So what can we take as a conclusion for that? I mean, right away you get this feeling that the urgent feels like, okay, don't use React clone element. This is the bad guy. Never use this ever, ever, ever. But that's not true. That's simply wrong, because if you look at it, well, it's maybe not the best thing in the world, but it has a lot of probably very good uses. If you look at it, it comes up. People in Reach UI, it's used in Material UI, in React Kit even. Not often, but for some reason it's helpful. So when you actually analyze such a change, or don't fall into the trap. That is probably a really important message. Don't fall into the trap to make wrong conclusions early on. And we took a little bit of time to really figure out what we think happened. I mean, you weren't 100% sure, but relatively. And if we looked at it, what actually happened is that. Well, let me go back to the code here. Is in this scenario, whenever you visited a tab, basically it wasn't only just rendering this new tab with the active tab, but it was also rendering the old tab, because it took away the active part. So whenever you and this is what we strongly think resulted in is like two major render trees that took very long time to render. Is on every tab change, you basically re-render the complete screen, at the old one and the new one. And even especially when you went back, you did the same thing over and over and over again. And this is very fascinating, because if you think about it, like, this code was written with a fascinating idea. Like, it led to the optimization for the initial render, because we weren't rendering all the tabs right away, but it cost a lot of overhead for each additional tab change. All right, and yeah, so what can you do at this situation? Well, blame the developer who wrote it. Well, maybe not the best idea, because if you think about it, this was actually a really good idea. I mean, we're dealing with like very slow devices that we have to support. So like, making this optimization and like reducing the initial loading time by making sure you don't render a lot was a really good idea, but just a mistake was made, and or maybe it wasn't even noticed, and it resulted in bad performance, but it was fixable. All right, so this was the first story. And yeah, one thing is like, this was like, has nothing to do with use memo, use callback and so on, but it was like completely different area. And it sometimes performance as doesn't need to do with the usual suspect. All right, this was the first part. Let's move on to the next one. What we already seen is these fantastic tools, performance and timeline panel, and I really like them to like, and you have them in Safari, and you can do remote debugging, and I mean, it's sometimes very clunky to set up, and it also can affect the performance of the device, and so on and so forth. But they really give you an insight, like what's going on, and where are things coming from, or and this is like, I'm very glad we have them. Otherwise, like, figuring out or measuring and investigating would be way harder. But nevertheless, sometimes it's really also nice to just use console log, and sometimes you even really need to, because these tools sometimes can't help you. And this is a story about a case where we also had to support actually a newer device, but so it was like recently ordered, but we got the feedback that the UI, the user interface, is very unresponsive on this new device. We knew this, or we had this experience with older devices. This was kind of expected, but not with a newer device. And it like, first of all, if you get the feedback the UI is unresponsive, this can mean anything. So we digged a little bit deeper, we talked to the people, and we actually got the device in, we tried it out, and yeah, really we felt it. When you click the button, it took a long time to actually make a change, like adding an item to a list, or doing a switching screen, like all these kind of things that's like, it felt there was a lag. And then people came up with very interesting ideas, and basically we had a lot of assumptions, and they were kind of already like not proven facts. It was like it was almost a bit scary. Like there was this like rumor almost going around that the event bridge from native to web view is slow, and this is not actually like that this is the problem, or the app is just too slow, and we will never get to a really good performance with this stack itself. Yeah, I was not bound by the stack, but it gave us some motivation to prove their assumptions wrong. And this was very interesting because, like, how do you do that? Like, I mean, how do you do test the event bridge? And one colleague came up with a fantastic idea. We can actually test this by using timestamps, just console log and alert. In this case, alert console log was enough. So what we did is we put a view in Android, in the Android native layer, on top of it that was measuring it's basically everywhere, and touch start, and then we put also the touch start handler on a HTML button. And same for the touch end, and we could measure the difference between the Android one and the web one. And to be honest, this was way longer than I expected, like 24 milliseconds or 70 milliseconds for touch end. Of course, you always also have to do this several times. I mean, this is just like one example. Why do it several times? Because if you browsers do garbage collection, so, or like there are sometimes these one by off errors that are errors, but like through garbage collection something can take very long that usually doesn't take long. And so if you retry and do again and again, at least a couple of times, and you see consistent results, then you can rely on these results. If you just do it one time, it might be very off from what is usually happening. And it was very interesting because the basically through this bridge or like it happened, there was a delay, definitely, with 24 milliseconds, 17 milliseconds, so around 20 milliseconds all the time. This delay was there, but I mean, this is way beyond the threshold where it's noticeable to humans. And so it was clear, like, this might add up to it, but it's definitely not the cause for like a really conscious delay that's happening. So with this test, we could rule out the assumption, and this was excellent for us because we knew, like, we don't have to look at this problem anymore, and we don't have to and this would also have been a very hard problem to fix. I mean, hard rewrite to a native app or React Native or something might have helped, but there's quite a lot of effort and might lead to a big change in the company direction or product direction. So how can we had this second assumption, like the JavaScript app is very, very slow. So we're looking at like differences on the actual device. It's like, again, like what's happening if we, let's say in web you have a touch end, and to the actual point in time where when item is added to a row. And the difference here was like 184 milliseconds, and it was constantly this time frame, and this is bad. This is like, there was no network request involved. This was just client side, and you already have a delay of 180 milliseconds. This was definitely too long. But the good thing is, with this data, again, if you do the same thing on other tablets, we could figure out that this particular device, or this tablet, there's a mistake. It should say roughly 190 milliseconds versus 70 milliseconds. 70 milliseconds was still slow, not ideal, but I mean, this is 2x. And one thing that this exercise did for us, and that was very good, it basically invalidated a second assumption. And then basically we had like this meeting where like, why could this be? And basically we figured out that the main cause was that even if it was a new device, the new device was definitely, like, we investigated further. There were two problems. It was underpowered, so the CPU and memory, and apparently when we dig deeper, the supplier used the touch interface that itself was very slow. So and this is like yeah, it was a very interesting deep dive, because yeah, we could have done, like, if we would have done this wrong, we might have ended up in a like half year of work, like trying to rewrite everything into native to like make it fit and make it faster, and we would have probably gained something, but in itself, if you have this root cause of slow hardware, you're screwed. Nothing would have helped, and so there was like yeah, and then you can see what you do with it. You either buy better hardware, or you accept it, and you can focus on features or other parts of the application. All right. One thing that is very important if you use console log or alert, don't use state now. This is really, really important. Use performance now. Performance now is, it exists in every modern browser, and it gives you a high resolution timestamp. Because if you do date now, you could really be off by a couple of milliseconds, and if you're measuring in milliseconds, it really makes a difference if you're off by a couple of them. So your tool to go for logging, if you're measuring the time between something, is performance now. And the good thing is, like, also be aware, you can use this to like really reduce the amount of like impact that you have. For example, you could, like, if you do a console log, this also has like a very slight, I mean, it depends on which, on the hardware as well, and so on and so forth. But there's a slight performance impact. And so what you can do is you can store it in a variable, on a constant in this case, and then you can store it before and after, and then you can make a difference, and then log it out, and then it doesn't affect the actual measuring of whatever you're measuring. So this is really neat. All right, and this was the second part. So now let's go to the third story or example. And what we're gonna talk here about is re-renders. And it might sound a bit harsh, but to be honest, like, this is such a real topic, and I don't really get it because I couldn't care less. This is like, if re-renders are happening, it's like, doesn't matter. Well, except, sorry, I have to bail out here of my own opinion. When it is related to inputs or animations, well, then it really, really matters. And then you should be really, really taking care of the re-renders. Why so? Well, let me explain this by two numbers that really, really matter, at least to me, when it comes to performance. This is 60 milliseconds and 100 milliseconds. Why 60 milliseconds? Well, because our screens, or most of our screens, like probably on, let's say, I don't know, it's a rough guess, but probably 99% of the devices that we have, your screen in your laptop, your screen that you have on your desk, these are all 60 frames per second, or 60 hertz. And this leads to the 60 milliseconds, because if you say 1000 milliseconds divided by 60, results in 60 milliseconds. So our screens, this is the fastest our screens can go, the 60 frames per second. And this means between two different frames, so one frame and the other, and then the next one, there's always a gap between 16.666 periodical milliseconds. And that means if we wanna have like smooth animations, or if we want to have like the absolute best performance that we can get out of our 60 hertz screens, is if we do everything in these 16.6 milliseconds. So this is basically our frame budget. So everything that we do, when here there's like this is the previous frame, then we have this budget here, this frame budget, and I want to thank Philipp Spies for this graphic, because this is really helpful, and it blew my mind the first time I saw this. We have this budget of like all the things that we can do, like to really get everything ready to let the browser know and like paint the next frame. And it's a little bit scary, because we like, it's not only our budget, but it's also like the computer has to do, or like the browser has to do a lot of things, like the input handlers. It has to take the browser has to do all the styling, painting, and so on and so forth. So it's actually less. I can't tell you really. It really depends on the change. But in general, you have not a lot of time to actually like stick to this 60 frames per second. And that brings me to the second number, and this is the 100 milliseconds. So 100 milliseconds. Why this 100? There's like, I think it started in the 70s. The first experiments happened of like what does feel instantaneous to a user when they do something on a computer, on a screen, and everything below 100 milliseconds roughly, I mean, varies between people and so on and so forth. So basically between the maximum, or the lowest that we can get is 60, and the 100 milliseconds is not perceivable by humans. So you don't consciously know that this wasn't instant. If there's an animation, or if you're typing and you have direct feedback, you unconsciously still notice it, but it's not really like, you don't really consciously be aware of the delay. Only above 100 milliseconds, it gets really like consciously, okay, I clicked something and I needed to wait. And so 100, that means there's the second point. What does this result in? Like, should we go for the maximum now, 60 milliseconds, or the minimum actually? What is it, the goal? Well, the goal is definitely to like be in that area of like 60 milliseconds of being in that area where it's unconsciously and consciously fast, and you don't notice any delay. But I mean, this is really tough. Like, we have network requests that go to different servers, and they definitely take longer than 60 milliseconds. So, and even like a whole page build up, it's like you will have a really hard time, even on a modern machine, to stay under 60 milliseconds. So there's like this rule of thumb for myself that I created, and that really comes together with these two numbers. Is like, if it's related to animations and text inputs, like really optimized to stay under these 60 milliseconds, and this, because this will have be a very like, it will have an effect for the users. But if you do something where you click a button and you add a list item or a link, there's like a one-time change where you where it's not so, like, the delay, if there's a small delay there of 70, 80 milliseconds, is because it's this one-time thing. It doesn't really doesn't have a too high effect on the or there's no noticeable effect for the user. While it's animations and text inputs, then there will be. So let me show you an actual example. where this matters, or what you can do to make this happen. Here I have landing page, and we have this sign up form for where you can enter your first name and email. And if you look at it with the React profiler, and you just rendering this page on my MacBook 2017, it takes, I mean, this is in React in dev mode, so this is still slower than it could be, but this took, the whole page build-up took 60 milliseconds. And this is a relatively simple page. So we have here the build-up, and this initial build-up, there's not, well, you can try to I don't know, get a more performant error boundary, or try to optimize the hell out of every component. But I mean, this will, like, making this faster will be tough. The best fix you can probably do here is, like, from a user perspective, is to server-side render it, because then the user, you don't have this React build-up that has to build up the whole DOM. You will get the finished DOM, and the browser can render it right away, and then React can attach the events. So this is the best experience for the in that regard. But yeah, this is a completely different story, and I'm not gonna go deeper into it. But there's one case that I want to focus on, and this is here when the user actually starts to type into this input. So when user actually starts and first, for example, types in an N, what can happen? Well, ideally, you only render the minimum that's needed, because you want to keep this time span relatively short. But what you can see here in this example is that there was some context. Probably, I mean, I didn't reproduce this, so probably this context provider should have been green here as well. But the I stitched together two screenshots. That's why it's not 100% looking like the way it should be at this moment. But what you can see here is, like, the navigation for some reason was re-rendering as well. And if you look at it, well, again, it's React in dev mode, so maybe it was like half of it, or I don't know. But this took a couple of milliseconds, and this is, like, as previously mentioned, if it's regarding inputs, really try to optimize for that. But why did it so? Well, there might be a feature that whenever an input is changing, you can go to the next step of a form, and then the navigation has to change, this is actually a real case that I encountered in the past. But there could be, you could have a different highlight on like which section of the page is highlighted, and so on and so forth. So this can definitely happen. But can you optimize this away? Well, not really, because if you have a feature, well, it's a feature, then it's a feature. So you shouldn't probably take this away if it's something that you actually want, because it improves the user experience, or is relevant for the user experience of this app or website. But what you can do is, well, or where you want to go is, like, maybe not always render the navigation, but maybe just render it when it's really necessary. And what you can do, because then you really have, so if you only render the input, like, a lot of times, but then only when it's necessary to change the navigation, that is already an optimization that saves you a lot of time, because the navigation takes a lot of time. Instead of this, like, 1.1 millisecond here, this took 6-7. So you really shave off a lot of, like, effort for React to re-render and then actually compute the new DOM. So let me give you two examples of how you could do that. One example would be if you have this form and you have like, let's say you have this situation where you want to pass the information to the parent, like which of the fields was focused. And so basically every time on focus, you pass the name of the field. And I mean, this is a very made up example, but it was the one I really wanted to come up with something simple and not take something out of context that is really large. But if you have this case, one thing that would happen here is every time you focus on the text, it would send up this would send up the event. Probably this would be better with change but focus, but yeah, I hope you get the idea. So every time basically its focus changes, it sends the whole event. But what you can do if you don't always want to send it, you can really leverage refs. This is like, refs are not triggering re-renders, so you can put anything in the refs, and you can leverage refs to basically store the information, which one was used, and then you can prevent this. Like if the focus would happen twice, well, it can on the focus event would be triggered twice. Then you have this case where this check here can really prevent from this from happening, because the state doesn't change, and so you can prevent this from happening, and that's really neat. So refs are a really good tool to like cache something locally and prevent things from bubbling up or triggering other effects, side effects, re-renders that you don't necessarily have to do if the state doesn't really change. Another one is if you look at, for example, use state per se. Well, here, for example, if you have an input on, there's like, you want to take the birth year, input for the birth year of a person. With use state, you can have the setter function, and then you can basically, every time this birth year is set, you can set the person to update the birth year. But there's a neat little trick with a use state, or like when you have a setter. If you return null in a setter, it doesn't update anymore. And this is really, really nice, because if you have, like, I mean, this is a complex object, so it would create every time a new object, which would mean every time you have the set person, it can't optimize it, and it would re-render the whole thing again. But if you return null, then it can actually prevent it. Yeah, this is a very simple thing, but in a couple of cases this can be, especially when you have a lot of like changes coming in, like a slider or something like that. This can be very handy to like avoid propagating events which are not needed. Yeah, and then what it results is, well, you might still occasionally have this re-render of this navigation part with these techniques, but the good thing is you don't have them always, and you more often result in, or at least sometimes result in, this situation, and this makes it faster. As said, I would in general try to avoid this, because all of these changes here, basically they add more code, they add more complexity. But yeah, when it comes down to animations or inputs, sometimes it's worth the struggle. And yeah, this was my third and final case. And I know this is like very different cases, but if you take one thing away from this talk, is every time it comes to performance, really measure. It's like this is the basis to make an informed decision. Everything else is like is stumbling in the dark. And keep it simple when you try to approach solutions. Don't overcomplicate things. Try the simple thing first, and I hope you will be surprised how often this turns out quite well. As a reminder, I'm Nik Graf. I hope you liked it, and if you want to reach out to me or have questions, feel free to contact me on Twitter or check out my website. And I thank you very much. Thanks for listening.
In the poll, we asked, do you think the performance of your React application could be better? And vast majority of people think that yes. I mean, 58% said 4 out of 5, and then 32% 5, and there is nobody that thinks that the performance could not be better. So I think it just means there's some work to do. What do you think of the result, Nik? Does it match to your personal feeling, or?
Yeah, I mean, it's interesting because of course, it always could be better. There could always be more tests. There could always be a better design system, and I think that's why the numbers are more on the right side. It's like people would love to see it better, but from my experience, there's you do the 80-20. If you have really a problem, then you also get the leeway and the time from the companies to really dig in. And other than that, it's like if it's good enough, it's mostly good enough. And there's only very few teams, products, companies who care about like excellent performance. Mostly it's like, okay, this is good enough. And React is really good at like better than good enough out of the box. That's why I think I rarely have to actually optimize performance with React. And then it's also very specific cases. And also if you use, if you don't do a lot of stupid things, you get pretty good performance out of the box. This is the neat stuff.
Yeah, that's a good point. I mean, of course, you can say that maybe React should do a little bit more, or maybe, I mean, a part has to do with these structures we have in JavaScript, like these data structures. I think if we had better structures, we could do a little bit more. But let's check out the Q&A questions from the audience. So Lucas is asking, or actually, let's see the other one. Someone's question is, what optimization are you most satisfied with? Do you have some good story to tell, or what's the coolest optimization you found?
Yeah, the coolest one is the first one that I actually showed, where it's like really from 5 to 1 second. This like with like just one line of code change. This was such a blast to like see it, and then I mean another one was I actually didn't do it. I just reviewed the code, but someone built a custom router with like custom caching and whatnot, and then in the end we just replaced it with an out-of-the-box solution, and it completely outperformed it. So it gained another 50% speed, and so like it's like I like simple things. So the last minute of my talk were cut off, and like one recommendation I wanted to take away from the whole thing is like try to do the simple things, and this often plays out really well. And maybe another library that I really like is Zustand. And if you look at it, this is not more than like 150 lines of code or so. It's always about the algorithms, but like also less code often indicates, well, this is not doing a lot. So that could be a hint that it can potentially be fast. I mean, you can still screw up a lot of stuff in 10 lines of code, but simple is often also performant, but it really depends.
I think it makes sense because then you can make maybe less mistakes. And the next question is from Lucas. He's asking, what's the worst optimization that you have seen, or like some like attempt or so? I think that's the point.
Yeah, the worst that I've seen was this route, exactly this router that I just mentioned, like building a custom router that promised to be faster than what was out there. And maybe at some point was, I don't know what happened, but it's like it added so much complexity. And in the end, like when we took it away and replaced it with a standard solution, it got better.
Then it was fast.
And that's like,
sense.
Yeah, horrible.
Yeah, cool. Then someone is asking, you mentioned that you got the tap switch down to 1 second, but it's still kind of bad. So did you further improve it or leave it to that?
Yeah, we managed to do a couple more of improvements further down the React tree to like remove renders and then it got faster. But yeah, it was not by much, like, I don't know, 600-700 milliseconds. And the problem was still like, as I mentioned in the second lesson, it's like, if you have a really slow device, it's like you basically banging your head against the wall and there's a certain limit what you can do. That's
true. I mean, normally what happens, there is one optimization that's kind of simple and it gives you most of the benefit, and the rest is a lot of time to pull off.
Yeah.
So I think we got that one, and then someone is saying that you should not use date now, but how about console time? Do you think it's as good as performance now? So this performance APIs?
I actually don't know. I've never used the console time. Best to read up on MDN, the Mozilla docs. They have like, look for the performance now, where they say like this is the good one, and maybe there's a relation to console time. I will also look it up. Maybe also the Mozilla docs mention console time.
Makes sense. I mean, there's cool timing APIs out of the books. Then someone is asking about React Memo. So will not using React Memo help to avoid a lot of re-renders? If you use this,
that definitely can. The thing is, so in the past, I don't know if you remember pure components, but the thing is, if you put pure components everywhere, then you can also actually lose performance, because now every time the React component is checking the props all the time. So if you put it everywhere, it can hurt. So my general approach is like, don't use any performance optimization, and only when you see when you actually see an issue, or you want to get to these 60 milliseconds for an animation, then actually look into like where to put the memo and optimize it.
It makes sense, because if you do parameter optimizations, then like you get tricky code that might not even perform. So what's your favorite performance trick or tip? If you have to choose one performance tip.
I don't know. None. It's just like it's every time a different story. It's like there's
like no one tip to choose, but it depends on the context.
I mean maybe useref. I really like useref to like cache something somewhere, and then especially if you build libraries, there's like, if this is a part that is used hundreds of times by a code base, and you put this one little optimization there, it can multiply the effect. And especially if you have to use useref everywhere, that would be bad. But if you can put it into one case that is used hundreds of times, or if you have like a custom hook that you use in your app hundreds of times, then looking for that places and using refs and whatnot to optimize, that would be nice. And why use ref? Because if you use ref, if you change a ref, it doesn't trigger a re-render. So you can you can reassign this, and you can be careful with it, but you can do a lot of things, and you can basically work around the React render cycle.
I think there's some cool trick related to storing previous state. So we can use useref and put the state there and track what happened in the past. can do really weird things with it. Then Sanvi is asking if you could use only one tool, what would it be? So I guess it's a performance tool. So do you have some specific tool that you prefer to use?
For performance, if it's performance optimization, then I think the best one is the Chrome. Well, yeah, I like the Chrome performance panel because it's in the end, like this is always showing you the real stuff. I really like the React profiler for measuring React performance, the renders. This is like it's optimized for that case, and it's really, really neat. But the problem is often the like you might do heavy lifting in a use effect or in some click handler, and this doesn't show up in the React profiler, at least not yet. I think Brian from the React team was working on that, but it doesn't show up yet. So the React profiler might look like everything's looking good, but then you have like some blocking tasks that is completely blocking the main thread for 200 milliseconds, and you don't see it in the profiler. So in the end, like if I really want to dig down, I always end up in Chrome performance.
Yeah, that's interesting. We still have a couple of questions, but I think we get back to those in the panel. And thanks for the talk, Nik. I think it was great, and we'll talk more later.
Cool. Pleasure.